everybody, I'm at Jacksonville University. Today we're going to be measuring the nitrogen levels of our St. Johns River. Nitrogen is a nutrient that plants need to grow. When nitrogen gets into the water, it feeds submerged aquatic vegetation, which then can provide food for herbivores, oxygen for gill breathers, and a habitat for many underwater creatures. The form of nitrogen we'll be testing for today is nitrates, as that's the form that plants use. The nitrogen cycle is a complicated cycle to remember, but the best way to remember the form that plants need is that nitrate ends in ate. So just remember that plants ate it. The unit of measurement we are going to be using is parts per million, ppm. So let's go ahead and test our nitrate levels today, October 11th, 2021. First thing we're going to do is collect our water sample. Then we're going to add 5 milliliters of the water into a little vial. I'm going to add 1 tablet, cap it, and invert until the tablet dissolves. And depending on the temperature of the water, the tablet will dissolve quickly or slowly. So the tablet is now dissolved. I'm going to add tablet number 2, cap it, and put it into a little protective sleeve and invert for about 2 minutes for the tablet to dissolve. We put the tube in a protective sleeve because the sun can cause the chemical reaction to change. So our second tablet has now dissolved. I'm going to take the tube out of our protective sleeve. I have a color comparator. I'm going to put the vial in one side, and then I have a color chart on the other side. So I'm just going to take a look and see what our levels are today. And it looks like our nitrate levels is about 1 ppm. Nutrient cycling in nature is what supports a healthy ecosystem and occurs naturally through decomposition of organic matter and fixing it from the atmosphere by bacteria, legumes, and certain species of algae. It does not take much nitrogen to fuel plant growth, but an excess amount can undermine the ecological integrity of our waterways. Eutrophication is when a body of water becomes overly enriched with nutrients such as nitrogen. This excess amount of nutrients drives algae blooms that block sunlight from reaching submerged aquatic plants and clog fish gills. As blooms die and decompose, oxygen levels are depleted, causing fish kills. They can also produce harmful toxins. There are many different species of algae. While blue-green algae, also known as cyanobacteria, is naturally found in our waterways, excessive nutrients from fertilizers, manure, industrial wastewater, and failing septic tanks can stimulate the growth of toxic algae blooms. Algae blooms are visible signs of too many nutrients in our waterways. Although most algae are harmless to human health, the St. Johns River has one toxic cyanobacteria species called microcystis. Exposure to this toxic algae can cause respiratory and skin irritations in humans and can make your pets sick. High exposure to toxins can affect your liver and nervous system. So what can we do to prevent these algae blooms from happening? Citizens can help prevent algae blooms and nutrient pollution by limiting the use of fertilizers, picking up dog waste, maintaining septic tanks, and reaching out to your elected officials to demand protective policies to reduce nutrient loading in our waterways. If you do see an algae bloom, be sure to avoid the water. Take action and report it to the Florida Department of Environmental Protection so that state agencies can understand the extent of the problem and the urgent need to reduce the amount of nutrients entering our waterways. Thanks for joining me today to measure the levels of nitrates in our St. Johns River, and we'll see you again on the river soon.